Welcome to the System2 Servo driver guide. This guide is meant to accompany the written documentation that I'll be referring to throughout the course of this video. What we're going to cover on this video are the resources that are available to you and where you get them, familiarization of the product, so we'll be holding it up and having a look at all the things it can do on the board. How we generally adjust a servo movement for range, type of motion and so on. What a viewport is and why it's important and how you want to configure that for your layout. We'll discuss the easy config. So there's a whole easy config section in there that automate the setting up of boards for you. And we'll also cover manually setting it up, which allows you to take control of anything specific and gives you more flexibility should you need it. We'll also talk about the feedback and trigger viewport system. Data comes into a board and data goes out of a board, and the feedback system, the data going out, is quite flexible and can be configured in a number of ways. So we'll cover that, and we'll cover why you might want to use it in a particular way or not. We'll discuss resetting and saving changes so that, the boards, for example, allow you to do what ifs, and if you don't like it, just revert to your previous settings, or if you do, then you can save it and it'll be permanently saved onto the device. How it saves states, so when you turn it off and turn it on, what do you get back? How does it know where things are? What we're not going to do in the video is cover generic System 2 type functionality. There'll be a dedicated video to that, and that'll apply to every System 2 airboard that we have. So it'll cover things like the background, the network monitor, that sort of thing. First of all, let's look at the resources available for your System 2 products. We have the primary source, which is the website. There's a dedicated landing page. So if you go to megapointscontrollers.com/system2, it'll take you to this page, and you can read about some generic overall information as well as our development roadmap. The important thing are the links at the bottom right. There's the System 2 playlist, which will take you to all the YouTube videos on System 2. So one playlist and they'll all be there. But most importantly is the web shop, which houses the documentation for each of the products. So if I click on the System 2 Servo driver, you'll see here under the documentation we have the user reference guide, and it's this document that's going to guide me through this video, and these are the general headers and topics that I'll be demonstrating to you. So let's familiarize ourselves with the Servo driver. This is the main socket. The top two connectors are for 12 volts power supply, and that is a regulated 12 volts at 1.5 amps minimum. And the lower two sockets are for CAN H and CAN L, which is your network connection. Each board comes with a Snap 2 terminal, so you can screw in the cables into this, and then you can install and remove the connectors as you need them. If you need to fit a termination jumper, you pop the little jumper onto the two terminal contacts here, and that's it installed. You would normally only ever fit this to the ends of the network. So if you had a network with 10 boards on it, only the first and last would be terminated. Next, we have all the connections for the 8 servos. The inside pin is the signal pin, and that usually goes to the lightest coloured lead on the servo cable. So if I bring a servo in and plug it into the first lead, the first set of pins, you can see that I've put the lightest pin on the inside with power and ground on the other 2 pins. There's only one button on this board here, and it's for the hotspot. So you press it and it starts the hotspot. That's covered in a separate video as it's generic to all System 2 boards. The last thing to note on the board is the processor chip here and Wi-Fi antenna. You probably want to keep the Wi-Fi antenna clear of other objects, cables and things like that. But it shouldn't be too critical, as you won't be using it except for configuring the device. Using the user reference manual as our guide, we can see there's a section servo control, and if I go to the first topic under there, it's center servos, and this will talk us through and guide me through the demonstration below. So I've attached a servo, and off to the right I've attached a panel controller with a button, and if I press the button you'll see the servo move. Press it again and it moves back. So the first task we're going to want to accomplish is to center the servo so that when it moves on your point motor, it moves the same amount each way. So if we go to the admin panel for the servo driver, we can push the two range controllers together, and that will cause the servo to immediately center. So if you think push them together, go cross-eyed, and it forces the servo into the electrical center position. This one's reasonably centered, so it's okay. You're not going for absolute accuracy, you're just trying to get it on the nearest spline on the shaft. And once you've centered it, you can go and put the screw back in to lock it off. So I'll put the range back to 500, which is the default on the low, and 500 on the high. The adjustment range is 1 to 1000 on each side. So if I'm operating the servo now, you can see I'm moving about the same on each way. Now, the left-hand side is slightly more movement than the right. See there, there's not quite as much. Now we have the ability to live adjust it as well. So if I take the high range and push it out, can you see the servo's moving in real time? So wherever I move it to, the servo's going to follow for that side of the movement. So because I've got this servo horn on top, the right hand side of this will be controlled by the high range, and the left hand side would be controlled by the low range. If I had the arm coming down instead, so it was on this way, then that would be reversed. So if I now operate the servo, you can see that the movement range has changed. If I move to the left side, I can now adjust the low range, and that will dynamically adjust as well, and the servo will attempt to follow me. So if I push the sliders as far apart as they'll go, you can see the full range of motion on the servo. I don't know if you can see it on the video, but the servo goes through an arc that accelerates and decelerates. It makes it look a little bit more organic than just a linear motion, and that's to simulate the acceleration and speed up of an electric motor. If I want them to go back to the way they were before, I can do a reload values, and it'll go back to the last stored values. And now when I operate, bang, up and down. Let's talk about configuring the V-ports on the servo driver. I've added a second servo now, and I've plugged it into port number 8. So I have the first servo on port 1 and the second servo on port 8. And if we look at the configuration screen for the servo driver, we can see that what I need to do first of all is reload everything back to its default state, so that the servo port, the physical ports, S1 and S8, are on the default ports of 1 and 8. So if I attach a button onto the panel controller on port 1, then the first servo will move. And if I attach a button onto channel 8 or port 8, the second one will move at its programmed speed. Let's move it back. If I have, for example, a crossover and I want to use the same button to move these, on the classic system we'd say, well, just plug it in here. You can do the same on this if you want, but why waste or use an additional panel controller port when you can do it all through the same port on the button? So input number 1 or servo number 1 is on V-port 1, and I'll just change servo number 8 to also use V-port 1. So I'll just override that with a 1. And now when I press the button, I should see both move with the same button push. Notice that each servo is still individually adjustable and has its own characteristics. So clearly, if this was a crossover, we'd want both servos to move together. So rather than try and guess what the speed is with the slider, I can just read it here, 166, and enter 166 into the speed box for physical port S8. Now when they move, they'll move together as a pair at the same speed. Maybe you want to reverse one of the servos because the facing points, the way they're wired, one is going in the wrong orientation. We can click the reverse. The servo jumps, and now when they operate in the reverse manner to each other. So it's quite flexible in terms of what you can and can't do. Let's just do a quick test of the speed range limits. So at maximum speed, it takes about 1 second for this guy to move. This is the first guy, 1 second. And on the slowest speed, I'll make port 8, this one, move as slow as it can, and it's about 30 seconds. Don't think anyone's counting, but it's ticking away. And we're done. So I knew we'd get there in the end. Now obviously whilst it's moving, this guy's going to take another 30 seconds. I can adjust the speed of that channel so it moves a little bit faster. And there we go. Now if you've been experimenting with the configuration page and you think I've made a bit of a mess, I want to go back, if you just select reload values, it will reload the values since the last save. So reload, and what it's done is it's put physical port servo S8 back onto vport 8, which was the default for that. It's set the speed to its default value, and for port 1, it's put the speed back to where we last saved it. So now when I press the button, just the first servo moves. So on the configuration page, you can think of the vport or virtual port as an address of each channel. And you're free to set this between 1 and 60,000. So there's quite a lot of space there for you to configure devices. So with the easy config, which is this option here, you'll see that if you mouse over the selection box, it will highlight the backgrounds of the vports here and the trigger and feedback vports. I'll cover the feedback and trigger vports in a minute. But what this is telling you is if you make a selection from this, these are the parameters that will be adjusted. So board 1 we're looking at 1A, and it is starting from 1 vport up to vport 8. If I select 1B, it will select the parameters for 9 to 16. And this is done, they're pre-canned solutions up to 20 boards. 10B is the last one, so it ends on vport 160. Though you are free to enter whatever value you like. If I put 22,500 on a vport, then that is now on vport 22,500. Doesn't matter what numbers you use, as long as they're unique for that particular port. But we've made it so that it's easy and fast to get going. Let's go back to vport 1. If I've been playing away and I don't know what I've done, again, just hit the reload values and it'll go back to the last saved settings. And there they go. Here's the starter kit contents, and we have a panel controller, which is configured as easy config board 1. And we have a servo driver, the first one as easy port 1A, and the second one in easy config board 1B. So the first 8 ports would be to this servo driver, and the second 8 ports or channels would be to this servo driver. If you wanted to expand that, then out of the box with the easy port configs, you would configure the boards on the left 1A, 1B, and then we go 2A, 2B, and the second panel controller would be Easy Config Board 2. So each of these has exclusive control over its servo controllers, and you can add them as you need to, and it's quite a simple but fast way to implement the system. What if we want something a bit more though? Well, we could have a panel controller on one side of the layout and another panel controller operating a mimic panel at the other side of the layout. And in this configuration, we've set panel controller 1 and we've got physical port number 8 driving the servo on port number 8. These are physical ports. And we've got port number 12 driving physical port 1, 2, 3, 4 on the servo driver. And that port is shared with this panel, which is panel controller 2 on physical port 1, and that's also sharing control of that output channel. And then we've got physical channel number 5, or port number 5 on panel controller number 2, and that's driving servo physical channel number 1. So we have exclusive control on the physical ports 8 and 1, and we are sharing control in this case on channel number 4. So we can mix it up as we need to. If we take a slightly more extreme case, we could assign ports so that we are from every panel sharing control of every servo driver, or sharing some, not sharing others. You can really mix it up as much as you need to. In this case, it would be a manual configuration, but getting the easy config, setting that as the starting point, is probably the fastest way to go about configuring this. So the demonstration bench is looking a little bit busier now. In addition to the Servo8, you can now see the panel driver board, and I've also added a relay driver and a 4-way relay module here. And when we operate the switch for the servo, you'll hear and see the relay module. You can see the red light. Let's move the wire out of the way. See the red light on and off. So what's happening is the LED test strip I've fitted to the panel driver has all of the LEDs fitted. So that's 32 lights. So you can see on channel 1, it's on one side and it's on the other. And when it's flashing, the servo is moving. So if we look at the servo driver board, we can see that first of all, the feedback port is on port 161. And 161 is the feedback for the LEDs on the panel. If I go to the panel driver, you can see here feedback port 161 is the output ports, or the LEDs for that panel. If I made 165 or port number 5 161 as well, then you'll see two sets of lights flashing. There they go, and back. I'll return that back to its default, and now we have just the one light flashing this way and this. So what's happening is on the feedback, the servo driver, when it receives a command on vport 1 to do something from this button, it starts moving and it sends a status back on this feedback vport. And the status at this point can be one of 3 different settings. It can be this side, or in motion. So if you want it to show you that something's in motion, then it will give you this flashing signal on the panel. If I slow that servo right down, you'll see that the flashing is correctly indicating the state of the motor. So you would use that. Say you had a gate, a barrier, or a set of points that you were moving and the motors were moving slowly, then it's important for the panel to tell you that there's something going on and it's in motion. Also, I find that useful where you've got multiple panels connected and a remote panel where there might be an operator. It would draw their attention to the fact that that particular accessory is moving. Now, if you've seen, well, you will have heard the relay clicking away in the background as well. Move these cables out of the way. And you can see the relay operates, but it's configured differently, and it's configured through this trigger V-port. And the trigger V-port throws or fires when the servo is at its computed center. So this relay will, in this case a frog polarity switch, would only change when the servo is right in the middle. See, it goes in the middle and it throws the other way in the center as well. And that's so that as your point blades are moving, and this would be particularly of interest to N-gauge modelers, then the polarity changes and avoids a short circuit. If I bring the speed right down, you perhaps see it a little bit clearer. As the servo gets to the center, it throws it. And then as it goes back, it doesn't. Now, if I didn't want this flashing light on my panel, then I can put it back on. I can put it on the same V-port as the relay is. So on the panel, it will be set to 161. Maybe I want to move it to 321 then, so that I get just an instant changeover. So if I go to the panel controller and I set it to 321, now this panel will not flash. It now fires when the relay fires. That's because I've just changed a simple V-port. Of course, remember what we do? We've made a mess, we don't know what we've done, reload values. And now it's gone back to its default. So what this gives you is a lot of power and flexibility should you need it. But the Easy Port config sets all of these boards up to complement each other out of the box. So all you have to do is say board 1, board 1A, and a relay driver, board 1A, and it will match, and then you'll get the action associated with that. Right, let's talk about these types of servo motion that we have modelled on the servo driver. I've tidied up the bench so we can just focus on the servo at hand. So obviously the default is points, you've seen that. You get this acceleration, deceleration, it's non-linear, end-to-end, pretty straightforward. And we've seen how we can adjust it with the range high, the range low, and the speed sliders. We also have a semaphore signal. So if I just select the semaphore program, now what happens is I'll get this crazy bounce and a pull off, crazy bounce and a pull off. And that's because generally semaphores work over a 45-degree range, not 90. So I could reduce the range of motion here a little bit and maybe slow it down. Let's see how that looks. And by the time you've fitted it to your semaphore signal through the piano wire and various other bell cranks and things that you might go through, you can adjust it, try it until it looks pleasing for you. The semaphore and the points can be reversed. So now I've put the bounce on the left side. And if I take the reverse light off, servo moves back, and now I've moved the bounce to the right. It stays within the endpoint boundaries that you've set. And finally, the wigwag, which may be of interest to American modelers. I just reset there to get everything right. So if I select the wigwag program now, it jumps to the center, which is the start position, and then it'll oscillate and it'll build up its oscillation to simulate the wigwag at the crossing. With our sound module, which is coming out later on this year, you'll be able to couple it to the ding, 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 ding type sound that you would associate with it. So we can see it's moving there and we think, okay, it's moving a little bit fast. So we can adjust it, slow it down. Maybe we want it to move more. Can you see now it's moving more to the right? Or maybe I want it to go more to the left. You have the full range of adjustability. There it is on maximum motion. So you really are at liberty to tweak to your heart's content. Maybe something like this is more pleasing. But you'll just adjust it, get it right, and then that'll be it. So you can just do a bit of this, bit of that type adjustment until you've got the sort of motion that you want. And once it's done, turn it off and it'll wind back down. There's no reverse on the wigwag. As System 2 develops, we may choose to add additional models. We have a few in mind. They'll be available through the software update feature, which is update firmware. In fact, while we're talking about firmware, you can see here when we start this, it says firmware up to date. If I click on it, it tells me I have the latest firmware installed. But if I want to see what the full release history of this product is, view full update history, and it tells us that on the 8th of January, the last update, the changes that we made during that update. I said I wasn't going to cover any generic System 2 features. I lied. I'll just cover a quick one now. I just did one a second ago on software updates, but the saving and reloading of values I think is important. So if you're setting your parameters as you wish and you've made a mess, as I've mentioned before, you would just go reload values, and that will reload the saved values that are stored on the device, and there they all are, and it's set back. Now you see the speed has always been over to the right, and that's because I set it and I saved it. So let's say I want to set the speed here to full speed. If I do the reload values, it's going to undo it. But if I do it this time and I save the changes, I get the message here, changes saved. And when I reload the values, it's back where I left it. So with my default set, if I now change something and I save the changes, then this will survive the change. So if I reload values or restart or reboot the board, you'll see that this will reappear at the right hand side. And there it is. So it survives the changes. So you're free to do the what ifs. If you touch the easy config, then you get the easy config settings loaded. Don't forget to save your changes if you wish to keep them. Of course, you might just be playing, that's fine. But at the end of the day, if you get in pickle, reset to defaults, save changes. The ultimate source for documentation are the Megapoints controllers website. Click the documentation link and it will take you straight to the product page. And on the product page, you'll find the user reference, which is the document I was using to follow before. Click and there it is. So I hope this video has proven useful to you, and I'll see you on the next video.